Today we're going to take a look at Harbor Freight's Armstrong brand USB rapid charging outlet. It is a 20 amp capable tamper resistant receptacle with built-in rapid charging, 3.6 amp dual USB ports. Let's get it open and take a look at its build quality. It does come with an included wall plate, which usually comes separately, so that's a nice bonus. Harbor Freight sells these for $15 and they regularly go on sale for about $10. For a 20 amp outlet with USB charging, that's pretty cheap. I think you'd have a hard time finding something else as capable in this price range. One thing I really like about this design is how the wires attach. You insert the wire into the hole and tighten the screw, and a plate clamps down against the wire, holding it in place. There's many types of connectors we could have used for the install today, but I chose to use the ideal push-in type. You'll also need a couple of extra lengths of wire and some basic electrical tools. I'm also going to use this Ames electrical tester that I also picked up at Harbor Freight to test the wiring. It only cost a few bucks. You can also just use a multimeter to test for power as well. Here's the outlet we're going to be replacing today. We're going to plug in the tester and see if it's got power and that the wiring is correct. Then kill power at your breaker. Unfortunately, the lights share a circuit with the plug, so I ran an extension cord to another room and hooked up a light. Next, I removed the ground from the old receptacle. I went ahead and just cut off the rest of the wires because it's the backstab type and I hate pulling them out, and there's still plenty of length left. We have two sets of wires here along with the ground wire. The white set is the neutral and the black set is the hot wires. Ground is the bare wire. I'm just going to strip these wires back a little bit to get them ready for the push-in connectors. You don't actually have to do what I'm doing here. You could just strip these and put the two whites to the silver screw on the receptacle and the two blacks on the gold screw and hook the ground up, and you would be good to go. I do like to do this because it makes it easier for me to change things out in the future. You can use any type of connector you wish here. I chose the ideal inch-or push-in type connectors because I like their form factor. They're easy to push into the back of the box and get out the way. It's a little weird that I like these push-in style connectors so much, but I refuse to use the push-in style connectors on outlets. The two white wires go together and then the two black wires go together. Make sure you strip your wires long enough to where they fully seat into the connector, but not too long that they leave exposed wire coming out the end of the connector. There's a strip guide on the side of the connector if you're unsure. I like to use some lines and pliers to help force the wire into place. I also really like the Wago lever nut style connectors as well. They are so expensive. The gray lever nuts that I showed earlier in the video, I don't quite recommend. They're a cheap knockoff version of the Wagos, and they're just not to the same standard. I'll go ahead and leave some Amazon affiliate links in the description for all the products I used in this video, if you guys are curious. Next, we're going to take the 3 extra pigtail wires and add them to the connectors as well, matching the same colors. Once they are all connected, I cut them to the desired lengths and then strip the ends to fit the back of the new outlet. I generally just do this to give me a little bit more length to work on the outlet if I ever have to pull it out for any reason. If you just want to hook up the outlet and save a little bit of money, then don't even worry about the connectors. For my wiring, I only needed a 3-position connector, but they do make these connectors in larger sizes, like 4 and 5 position. Installing one of these outlets isn't too bad for your typical do-it-yourselfer. However, wiring can get a lot more complex than what I have here, and if so, you might want to contact an electrician. This outlet won't work for you also if you have a light switch that controls a single socket on the outlet. On a regular outlet, you can remove a tab between the two screws that allows each socket on the outlet to operate independently. The wiring will also be slightly different. You may have a red wire. I'm not going to go over that configuration because it's not relevant to this outlet since it doesn't work with it anyway. Make sure to loosen the screws on the outlet before inserting the wire into the holes. Once the wire is inserted, tighten the screws down and give the wire a good tug to make sure it is securely fastened. The bare ground wire goes to the bottom green screw. The white wire will go to the silver side screw and the black goes to the gold side screw. Also, if you don't trust sticking the wires in the holes, you can also do it the old-fashioned way. by putting a little curve on the end of the wire and wrapping it around the screws. The wire should hook around the screw in a clockwise fashion. This way the screw will close on the hook as you tighten the screw. After all the wiring is hooked up, we're going to shove the wires back into the box. The wires can be pretty stiff sometimes. You just got to force them to the back of the box. Sometimes I'll use a pair of pliers to push them back into the back of the box. I also try to separate both connectors to both ends of the box just to be more safe. Then I push the outlet as far back into the box as I can before screwing the screws in. I don't generally use power tools to screw in this part because it's a plastic box and I've seen them get stripped out before. So I'm going to speed up the video here just because it takes a long time with a screwdriver. It's the same thing with the cover plate as well. I've seen people use drills to try to screw in the cover plates and end up cracking them. Once we get the cover plate back on, we're done with the install and we just have to head back to the breaker room and flip our breaker on, get our power back on. Yay, we got power! Let's give the USB port a test real quick. Looks like it's working as well. I believe the 3.6 amps are shared between the two ports because no matter what I tried, I couldn't get it to go beyond 1.8 amps. I do recommend these outlets, but only due to their price. There's a lot better options out there like USB-C capable ones with power delivery and all kinds of different charging protocols that this does not support. But if you just need a cheap basic USB capable outlet, this one is hard to beat for the price.